In this lesson, we are going to continue with the classification of differential equations. We are going to learn about linear and then nonlinear differential equations in this lesson. Differential equations can also be classified into linear and then nonlinear differential equations. We are going to look at how to differentiate between these two types of what? Linear equations. Okay, so we see that a differential equation is linear if the following conditions are satisfied. The first condition is the dependent variable and all its derivatives only occurs to the first power. That's the first condition here. And then the second condition is there are no terms involving products of the dependent variable and the derivatives of the dependent variable. So there mustn't be any terms that what involves the products of the dependent variable and then the derivatives of the dependent variable in it. Okay, there mustn't be any term like that. And the third option is there are no transcendental functions, okay, which means there mustn't be trig or log functions that involves of the dependent variable or any of its derivatives in the equation. So when all these conditions are satisfied, we see that what the equation is a linear differential equation. When a single one of these conditions is not satisfied, then the equation becomes what? A nonlinear differential equation. Let's take some examples to help us understand this better. So I have the first example here. I have y prime prime plus y equals what? 0. And we know y prime, okay, will be what? dy will be dy over the x. Okay, so y prime prime will be the second derivative of y with respect to what? X. So this differential equation now becomes d squared y over the x squared, which is the second derivative of y with respect to x plus what? Y equals what? 0. Is this a linear differential equation or a nonlinear differential equation? So let's look at the conditions. The condition says that what? The dependent variable and all its derivatives only occur to the what? To the first power. So that's the first condition. So now let's identify the dependent variable. So in this case, the dependent variable is what? Is y. And then the independent variable is what? Is x. So the dependent variable and all its derivatives only occur to the first power. Okay, so we have what? The second derivative here and it has what? A degree of what? 1. Okay, that's what? The first power. And then we have the dependent variable itself here, which is also what? To the power of 1. So the first condition is what? Satisfied. Let's look at the second condition also. There are no terms involving products of the dependent variable and the derivative of the dependent variable, which means what? There shouldn't be any term where the dependent variable will multiply any of what? Its derivatives. So looking at this equation here, this dependent variable here is not multiplying what? Its derivative that we have here. So what? This condition is also satisfied. And then the third condition also says what? There are no transcendental functions of the dependent variable or any of what? Its derivatives. And then looking at this equation, we don't have any transcendental functions, which is the sine, cosine, log, exponent. We don't have any transcendental function that has what? The dependent variable in it here. So this differential equation here is a linear differential equation. Okay, let's take another example. Okay, so I have a second example here, which is the second derivative of y with respect to x plus sine of y equals 0. So let's see whether this is a linear or non-linear differential equation. So let's look at the conditions. The first condition says that the dependent variable and all its derivatives only occurs to the first power. Okay, so we know why is the dependent variable here, and then we have what its second derivative here, and it is to the what power of 1. Okay, so this condition is satisfied, right? Because the dependent variable and then all its derivatives only occur to the first power. So the derivative of the dependent variable that we have here is occurring to the first power. So this condition is satisfied. 2. There are no terms involving products of the dependent variable and then the derivative of the dependent variable. This condition is also satisfied because what there are no products of the dependent variable and then any of its derivatives in this equation. Second condition satisfied. Let's look at the third one. The third one says what there are no transcendental functions of the dependent variable or any of what its derivatives. The sign here is a transcendental function, and then the y here is what is the dependent variable, and we have a sign of y here, but I said what there shouldn't be anything like this because what that's what the third condition says. Okay, it says that what there are no transcendental functions, okay, of the dependent variable or any of what its derivatives, but here you have what a transcendental function that involves what the dependent variable. So this sign y here, okay, makes this equation what a nonlinear differential equation, because what we have what sign of what the dependent variable, which the third condition says what there mustn't be any term like that. So this is therefore what a nonlinear differential equation. Okay, let's take another example. Okay, so I have the third example here. I have x squared multiplying the second derivative of y with respect to x plus dy over dx equals sine of what x. So from here we know that what y here is the dependent variable. Okay, so now let's test the conditions on what this differential equation that we have here. So you said the dependent variable and all its derivatives only occur to the first power. So this is the dependent variable, that's y, and then we have what the first derivative and then the second derivative. Okay, and they are all occurring to what to the first power. So the first condition is what satisfied. Let's look at the second one. The second one also. The second one says what there are no terms involving products of the dependent variable and the derivatives of what the dependent variable. So looking at this differential equation here, you see that what, there is no term here where the dependent variable is what is multiplying what any of its derivatives. So the second condition is also satisfied. Let's look at the third one. There are no transcendental functions. Okay, there are no transcendental functions of the dependent variable or any of its derivatives. And looking at this also here, there is no term like that because what this x here is not what the dependent variable, it is rather the independent variable. So therefore this differential equation is a linear differential equation because what it satisfies what all these conditions here. Okay, let's take another example. Okay, so I have this example here. You have y multiplying y prime prime plus y equals what 0. Is this a linear differential equation or a nonlinear differential equation? So let's look at this. So I can rewrite this as y multiplying the second derivative of y with respect to what x plus y equals what 0. So let's see whether this is a linear or non-linear differential equation. So from the first condition, the dependent variable and all its derivatives only occur to the first power. And then this is the dependent variable here, which is y. It is to the first power here, and then the derivative here, which is the second derivative, is also to the first power. So the first condition is satisfied. Let's look at the second condition, which says what there are no terms involving products of the dependent variable and the derivative of what the dependent variable. So looking at this equation here, we have what y to be the dependent variable, and it is multiplying what its derivative. But the second condition says what there shouldn't be any term like that. So this y here multiplying what its derivative here, which is what a dependent variable multiplying what its derivative, makes what this differential equation what a non-linear differential equation, because what it is going contrary to the second condition. So from here we can see that this is what a non-linear differential equation. Okay, so that's the last example for this video. I'm going to give you some questions to also try on hands-on. So let's look at these questions. So the first question is the second partial derivative of u with respect to what x plus sine of y equals 0. Is this linear or non-linear? For the second question also, I have u multiplying the second partial derivative of u with respect to what x plus x equals what 0. Is this also a linear or non-linear differential equation? Let's try our hands on these two questions. You can send your answers to me in the comment section. Thank you very much for watching this video. Please don't forget to like and subscribe to the channel so that anytime I release new videos on this course, you will be notified.